Okay, so hopefully you just got through your eliminating fractions one. You took a little break, maybe you practiced some more. So remember, practice is what's going to make these really come to life for you as far as understanding the process. With math, you have to continually practice. Otherwise, it is a language and you will lose it. So with this video, what I'm going to do is I'm going to go over section 1.1. So the eliminating fractions was kind of the preliminary, and then we're going to jump into 1.1, which is linear equations and inequalities. So let me share my screen here. Hopefully this is working well for you so that when you are working through this process, you can, go back, watch the videos again. You can use your Help Me Solve in my math lab. There are lots and lots of resources. Now, for those of you who are in San Antonio, you can go on to the Northwest Vista campus, and there are actually two different math labs. One is one-on-one tutoring, and the other one is kind of group tutoring where you sit and do your work and there's tutors wandering around. So there's all kinds of options and resources for you. If you are not by the Northwest Vista campus, any of the Alamo College campuses has math tutoring labs. So I'm on the Northwest Vista campus, so that's why I know that one the most. Okay, so this again is homework 4. So we're still in homework 4. This one is going to be due September 11th, Monday, September 11th. So this is the only one due. Homework 4 is the only one due plus a quiz. So you have lots of time to practice. So I hope you are not procrastinating. Procrastinating is a death knell in this class. Math takes time. And if you are waiting until 10 o'clock on the day it's due at night and trying to get it done, you aren't learning anything, you're just getting it done. So I'm always going to tell you, don't just get it done, really dig deep and figure out, all right, what am I doing? Why am I doing this? Because again, all of these techniques is a buildup, and we're just going to keep building on our techniques. Okay, so this one is section 1.1. This is, so the whole idea of Coreq and all of that, this is actually the college level portion. So the eliminating fractions is the Coreq portion. So you're going to have a lot of topics that are entwined into the college level course, so that by the time you're done, you've had all the college level course and you get credit for college level. Okay, so this is 1.1, linear equations and inequalities. So what is a linear equation? So linear equation is very easy to visualize in your head. You think of a string or a line or anything that's long and linear, all right? It's a linear equation. How do you know that something is linear? Well, when you look at how the equation is set up, this is in standard form, you see there's an x, right? This is x to the first power. So that will always tell you that you have a linear equation. If you have x to the first power, it's linear. If you have x to the second power, that's a quadratic, which we have a whole section on. If it's x to the third power, that's a cubic function. And then every function has different qualities and characteristics. So this particular one is linear. That means that you have it's steady, right? It will grow at a steady pace, or it will decline at a steady pace. Okay, it's the same pace throughout. So that's what makes it linear. So this is this ax plus b equals 0. This is in standard form. You may have seen it, the right pencil here, seen it written as y equals ax plus b. Some of you are probably already jumping to a linear equation as mx plus b, y equals mx plus b, which is the slope-intercept format, which is, we'll get to it. But this is just the standard format of a linear equation. The x value is to the first power. The A and the B are values, they're numbers, okay? Those are called the coefficient or the constant, okay? If the equality symbol is replaced by less than, greater than, less than, equal, or greater than or equal to, then it's called a linear inequality, okay? So what we're going to do is we are going to solve for a linear equation or a linear inequality. The difference between the two is with a linear equation, when there's an equal sign, there's one answer. That's it. You have one answer. With a inequality, you have a series of answers. So it could be all the values greater than 2, or all the values less than 5. So, or all the values between 2 and 5. So that's what makes the big difference between an equation has one answer and one answer only, and an inequality has a series of values. So we're going to start with an equation because we have an equal sign, okay? So when we're solving, if we go back to the very, very basics, like what I call the one-step equations. So the one-step equations would be something that looks like this, right? It's some value x, and we can use any variable we want, but because we're talking about linear equations, we'll keep it as an x. So some number plus 3 is going to equal 15. Well, most people can logically think this through and go, oh, it's 12. Well, 12 plus 3 is 15. But if you mathematically work it out, you always think in opposites. So since we're adding 3, if I subtract 3 from both sides, what happens is that cancels that. And basically what I've done is I've moved this 3 over to the other side. And I've crossed that equal sign, so I have to go in the opposite direction as far as the numbers go. So 15 minus 3 is 12. And then again, with these, you always can double check. Plug that back in. 12 plus 3 does equal 15. You're good to go. So this is the addition principle. If I had x minus 4 is 12, right? So again, most people can think this through and go, oh, what minus 12, or what minus 4, so like 16, right? You can kind of logically think it through, but mathematically we can show it. If it's a subtracting 4, we're going to add 4 to both sides. And remember, the whole idea is to keep this balanced, right? So if I do the same thing to both sides, I've kept it balanced. I haven't taken off on one side and added to the other. On this case, I'm adding to both sides. So that cancels. The goal always is to get x by itself. So x equals 12 plus 4 is 16. And again, I can check it. 16 minus 4 does equal 12, so I'm good to go. These are one-step equations. This is the addition principle. The other one is the multiplication principle. So now I'm multiplying. Notice I don't have a plus or minus sign in between. So now I'm multiplying. So what's the opposite of multiplying is dividing. So I'm going to divide both sides by 3. And again, the goal is to get that x by itself. So x equals 5 makes sense because 3 times 5 does equal 15. And then the other one is if I am x divided by 2, say equals, 10. So with these one-step ones, you can logically think it through. What divided by 2 is going to give me 10? You can probably guess 20, but mathematically, let's show it. So if here I was multiplying and then divided to get my answer, here I'm dividing, so I'm going to multiply to get my answer. So again, it's always the opposite. So that cancels, and my x is by itself, so x equals 20. So these are all one step. Then we go to two-step, and it's just a combination. What we're doing is we're combining these two processes. So we have, say, 2x plus 3 equals 13. So now with the two-step, we're going to get rid of the 3 first. That cancels, so I end up with 2x equals 13 minus 3 is 10. And then I'm going to divide both sides by 2. So I get x equals 5. Okay, and again, I can check. 2 times 5 is 10. 10 plus 3 does give me 13. Okay, so this is an example of a two-step equation. So from there, so most of you should be extremely comfortable with those two, the one step and the two step. Now, when I come over to example 1, this is a multiple step. Okay, you can see, oh, I have variables on both sides of my equation or my equal sign now. So what I'm going to do is I'm going to move this 6y and add it to my like term. And I'm going to do that anytime I cross that equal sign, I have to do the opposite. So when I'm moving the whole thing over, I'm just adding the opposite. So 6y minus 6y, that cancels. 3y minus 6y, that gives me a negative 3y. And then I just keep writing what I haven't worked with. So now this should look just like your two-step equation, right? We have a variable. We're going to get rid of the minus 4 by adding 4. And I get negative 3y equals negative 15. And again, this is where you have to know how to work with your sign numbers. So I'm going to divide by negative 3. That cancels. So I get y equals negative 15 divided by negative 3 gives me a positive 5. Okay. So again, I can check it. 3 times 5 is 15. 15 minus 4 is 11. 6 times 5 is 30. 30 minus 19 is 11. So it does check. Okay, so you can always double check to make sure that these are correct. So when you have variables on both sides of the equal sign, you want to move all the variables to the left. And it really doesn't matter right or left. It's just most people are comfortable moving everything to the left. You could have brought the 3y over to the right, and that will work also. Okay, so here is where now example 2 and 3 now is where we are going back to our eliminating a fraction. Okay, just like what we did. So we're going to find a number that 4 and 6 will go into. So 6 is the bigger number. 4 will not go into 6 evenly. So we start from the multiples of 6. 6 times 2 is 12. 4 goes into 12 evenly. So we're going to use 12. Okay, so 12 times, and remember, we're putting our parentheses around these binomials. Minus, don't forget the minus sign. 12, oh, I forgot over 4. 12 times 2x plus 3 over 6, and 12 times 4. Okay, so we're going to reduce. So 12 divided by 4 is 3. 12 divided by 6 is 2. And 12 times 4 is 48. So again, we're just kind of keeping going. We're going to keep cleaning up. So now we're going to distribute this 3 through. So 3 times x is 3x. 3 times 8 is 24. Going to distribute that negative 2. Remember, that's a negative sign. So negative 2 times negative 2x is a negative 4x. Negative 2 times 3 is a negative 6. Now I'm going to add my like terms. 3x minus 4x is a negative x. 24 minus 6 is a positive 18. And now I'm going to subtract 18. Sorry, I got lost on where I was. So 48 minus 18 is 30. So this is a negative x. This is a negative 1x. So we are going to divide both sides by negative 1. So I have x equals negative 30. So clear. Okay. So if you are struggling with the whole idea of eliminating fractions, go back to the eliminating fractions video. Look it up on YouTube, whatever you need to do to be real comfortable with eliminating fractions. All right. Okay, so if we were in class, if this was live, I would say, all right, now you guys try this one and put your answer in your chat room. So let me just walk you through this. So again, what number will both 2 and 3 go into? So 3 is your bigger number. Obviously 2 will not go into 3. So 3 times 2 is 6. 2 does go into 6. So I'm going to use 6 as my common multiple. So 6 times x plus 2 all over 2 minus 6 times x over 3, and then 6 times 5. So now I'm going to reduce. 6 divided by 2 is 3 times x plus 2. And you notice now they've kind of combined, right? Here's a binomial here and a monomial here. So we can combine it. Just remember, if there is a binomial, trinomial, whatever it is, you want to put it in parentheses so that you remember you're distributing this value through both. Okay, so 3 times x is 3x. 3 times 2 is 6. Minus 6x equals 30. So again, don't forget that negative. That negative 6 times x is negative 6x. So now I'm going to add my like terms. So 3x minus 6x gives me a negative 3x. Plus 6 equals 30. So now I'm at my two-step equation. So anytime you're doing these, you do get to a point where you have a two-step equation. 30 minus 6 is 24. And now I'm going to divide both sides by negative 3. So x equals negative 8. Okay, and there you have it. All right, so now we're jumping to inequalities. Okay, so inequalities just means that there is a less than sign, a greater than sign, a less than an equal, or a greater than an equal. So the process is exactly the same thing, except with an inequality, there's one special rule that we have to keep in mind, and it's a rule that happens quite often, and it can be forgotten quite often. So before we get into solving these, what I want to do is I want to make sure you understand there's a couple different ways to write your answers. Excuse me. So remember, when you have an equation, there's one answer. When you have an inequality, there's a series of answers. So I like to graph my answers, and then we can write it in interval notation. The set builder notation, we're not going to have to worry about too much. So it's just another way to write the answer. In my math lab, they like interval notation. So that's what we'll stick with. So with interval notation, you're showing an interval. So remember, there's a series of answers. So you're showing an interval. You're showing the whole series of numbers that will satisfy the solution to this inequality. So if you have less than or greater than, that is an open circle, right? And an open circle means it's not included. So you're going to use parentheses. Okay, if you have less than equal or greater than an equal, that is a closed dot. That means it's included. So we're going to use brackets. Okay, so this one is not included. And this one is included. In other words, it's part of the solution. Okay. So that's something that you'll need to know as far as interval notation. And then if you use negative infinity or positive infinity, because sometimes the answers go on for infinity, you're going to use parentheses for those also. So the only time you'll use a bracket is if you have the equal sign underneath your inequality. Okay. All right. So that's really the main, what the interval notation is all about. So let's go ahead and solve example 4. So we're going to do it exactly the way we do with an equation, right? We're going to get rid of the 8 first by subtracting 8. So this is just a two-step equation. We end up with negative 2x is less than negative 4, because 4 minus 8. So this is the big change right here. Whenever you divide, when dividing by a negative, you have to flip the sign. Otherwise, it doesn't stay as a true statement. So in other words, if I had negative 2 is less than 3, that's a true statement, right? But if I multiplied both sides by negative 1, I'd end up with 2 is less than -3. This is a false statement. So that's why you have to flip the sign, because as soon as I flip it, now I have a true statement. So that's whenever you divide by a negative inequality or a negative value. My writing is terrible. Let me try that one again. When dividing by a negative value, you're going to flip the sign. Okay, so over here, we're going to divide by a -2. So I get x. I'm going to flip this over, and -4 divided by -2 is +2. So graphically, it looks like this. It's an open circle, and it's all the values bigger than 2. So interval notation, it's a parenthesis, 2 to infinity parenthesis. Okay, so there's 3 different ways to be able to write your answer. This is interval notation, this is with an inequality, and this is graphically. Okay, so the big change is when you divide by a negative, you have to flip the sign. Okay, all right, so this one is, now you have an inequality where it's basically 2 different problems, but we can do it all in as one unit. Okay, so we're going to subtract 6 from both sides, all 3 sides actually. It cancels there. So I have 5x in the middle. Don't get your symbols mixed up. 21 minus 6 is 15. Don't get your symbols mixed up. They're the same. -4 and -6 is -10. Okay, so notice I'm just using this setup, and I'm solving across the whole, all 3 parts. All right, so now I'm going to divide by 5 on all 3 parts again. That cancels that. So my x is in between 3 and -2. That's what this means. So x is less than 3. So if I was graphing this, graph it over here. So it's all the values less than 3, and x is greater than or equal to -2. So notice I'm reading it from the x, right? I'm reading it from the x. X is greater than -2. So it's including -2, and it's going that way. So it is all the values between -2 and 3. So as interval notation, it would look like this. Because it includes the -2, I use a bracket. It doesn't include 3, so I use a parenthesis, but it's all those values in between. Okay, so inequalities, you're using the same techniques of solving, and then using interval notation, because there's more than one answer. All right, so again, I'm going to give you a minute. Pause this. You guys try it, and then we'll go from there. Okay, we're back. Let me share my screen again. Okay, so walking you through this. So hopefully you guys have already done this. So let's see if you did it correctly. So the first thing you should have done, anytime you see a number outside of parentheses, you're going to distribute. So we end up with 3x minus 3 less than or equal to, and then distribute here, 5x plus 10. And notice this -5 is outside the parentheses, so it has nothing to do with your 5 that you're multiplying. So now we're going to add like terms. 10 minus 5 is 5. Okay, so now we're going to bring our x's to the left. So I'm going to bring this whole thing over to the left. That cancels it. So I get -2x minus 3 less than or equal to 5. And you can see now we have our 2-step equation. So we're going to add 3 to both sides. So I get -2x is less than or equal to 8. So here is where we are dividing by a negative. So we have x. I'm going to flip that inequality sign over. So x is greater than or equal to -4. So graphically, it's going to look like this. Solid. And it's all the values bigger. Interval notation, it includes -4 all the way to infinity and parentheses. Okay. All right. So with this one, all you're doing is you're writing the correct intervals. So it's a profit occurs between 70 and 250. So with interval notation, we go from 70 to 250. It says nothing about including 70 and 250. So that's why it's not included. That's why I use parentheses. It's between 70 and 250. Okay, and then a loss occurs below 70 and above 250. So if you look at that graphically, it would look like this. Below 70 and above 250. And again, it doesn't say including it. It just says below and above. Okay, where this one graphically, it would look like this. So it's all the values in between. Okay, so this loss would be from -infinity to 70. So notice we're going low to high, and that's a union symbol, 250 and above. This is union, or it means and. It's another word for and. Okay, so that's just being able to write in interval notation. So now we're going to get into word problems. All right, so word problems are the nemesis of many, but if you think about it, word problems are life, right? You're not going to go to a job and your boss is going to hand you a sheet of 20 equations and says solve these. That's not how it works. What does happen is you come in and your boss says, hey, we need you to identify where our marketing is losing customers. And so you're going to use all of your problem solving skills, and that's what you're learning is problem solving skills, to be able to find where the errors are, where you're losing customers, where you're losing money, how to increase your profit, all of that. Okay, so here we go. So this is just a technique of your brain learning to problem solve. All right, so an employee of a furniture store earns a base salary of $2,500 plus 10% commission on all sales over $7,500. How much must the employee sell in 1 month to earn at least $5,000 for the month? Okay, so there's a lot of numbers going on there. So let's break it down. We have a base salary of $2,500. Okay, that means they're going to earn their $2,500 whether they sell anything or not. All right, they have a commission of 10%, which is 0.1. So remember, you take your decimal, you move it over twice. Okay, so 10% on everything over 7,500. So if we're selling stuff, anything over 7,500 is going to be where we're earning our commission. Okay, so basically what they're saying is up to $7,500 in sales, you're earning that $2,500. Anything over that, you get the 10% commission. So you're not going to get 10% commission on the 7,500. You have to take that 7,500 away. That's like your base salary. That's what your base salary is based on. So we're going to take away the 7,500 of our sales in order to get a commission. Okay, does that make sense? You're taking away the 7,500. So it's your sales minus 7,500. So here's an example. Let's say you have sales of 10,500. That's how much you made. Well, your 10% commission is only going to be on the 10,500 minus the 7,500. So you are only going to get commission on $3,000. Okay, everything over and above 7,500. That's why you have to take away the 7,500. All right, so these functions or these equations or inequalities are, especially when it comes to commission, is the basic setup is your base value plus your commission. And we want to make at least $5,000. So at least means I don't want to make less than 5,000. I want to make 5,000 or more. Okay, so that's where your inequality comes. So our base salary was 2,500. Our commission is 0.1 times X minus 7,500 is greater than or equal to 5,000. And so now here's your equation. Now you're going to distribute this 0.1 through. So 2,500 plus 0.1x minus, and then 0.1 times 7,500 is 750. And I'm using my calculator just to double check. Okay, so 2,500 minus 750 is 1,750 plus 0.1x greater than or equal to 5,000. Okay, so I just added my like terms. So now I'm going to move my 1,750 over by subtracting. So 5,000 minus 1,750 is 3,250. And then I'm going to divide that by 0.1. So my sales has to be greater than or equal to 32,500 in order to make $5,000 a month. Okay, all of a sudden commission doesn't sound so great. You have to sell 32,500 in order to make 5,000 a month. Okay, all right. Now, one thing about business algebra and business calculus is it's always good to be able to interpret. So if I were to type this in, let's see if it'll let me. I'll do it over here. So example 8. I need to sell $32,500 worth of furniture in order to earn $5,000 per month. Okay, you should be able to interpret your answer every single time. Otherwise, what's the point, right? So what? That you can do math. Can you interpret your answer? Okay, all right, so I'm going to pause. You're going to try this one, and when you come back, this answer is going to be there. So hopefully you will stop the video, try it, and then when you come back, we'll see if you did it right. Okay, here we go. Let's see how you did. All right, so is that what you got? 47,000? Okay, so let's make sure you set it up right. So base salary of 400, commission is 5% over 35,000. So here's your 0.05, and here is your X minus 35,000, because again, it's everything over the 35,000. And then has to be at least, so greater than or equal to 1,000. So then we distribute the 0.05 through, we add our like terms, so we get 0.05x minus 1,350 is greater than or equal to 1,000. So we're going to add 1,350 to both sides. So 0.05x greater than or equal to 2,350 divided by 0.05. So you get x is greater than or equal to $47,000. So to interpret, I need to sell $47,000 worth of merchandise each week to earn at least $1,000 a week. Okay, so you have to be a very good salesman to get these right. Okay, so this one, I'm going to go ahead and do this live with you. Well, not live, you're watching video, but I'm going to do it with you because it's set up a little bit differently. But this is perfect for all of you who want to buy a car. Okay, this is our last one. I just lie. Oh, yes, I did lie. Sorry, not last one. Okay, so whenever you're buying a car, your car is the purchase price. So that we're going to call P the purchase price. And then your tax is this tax times the purchase price. So in this case, our tax is 0.085 times P plus any title fees, title licensing fees. So this is the setup. Okay, so we have the purchase price plus our tax plus the fees of $190 is a total of $28,400. The question is, what's the purchase price? So we're looking for P. That's what we're looking for. So the price of the car, the purchase price of the car, plus the tax on the purchase price, plus any fees was a total of $28,400. Okay, so it's just a matter of adding like terms. So remember, this is a 1P. So 1 plus 0.085 is 1.085P plus 190 equals 28,400. So again, two-step equation. We're going to get rid of the 190 first. And we get 1.085P equals 28,210. Then we're going to divide both sides. So hopefully you're seeing this pattern. It's you get rid of the constant and then you divide by the number by the variable. So P is going to equal 26,000. So that is the purchase price. So 26,000 is your purchase price. You paid, whatever the tax is, 0.085 times 28,000 or 26,000. So just your taxes would be $2,210, so $2,210, and then the license and title fee of $190. So that's all the values that bring you up to the 28,400. Okay, so again, to interpret this, I paid $26,000 for the car. Plus tax, what did I say, 2210. Plus the 190 in fees to equal 28,400. Now, if you aren't sure, add it all up. Do 26,000 plus 2210 plus 190, and there's your 28,400. Okay. All right. So now here's the last one. All right. So here are just the different terminologies that you're going to need to know. Break even is when you're not losing money, but you're not gaining any money. And how you find that is the revenue equals the cost. That's right here. Revenue equals the cost. That's going to be your break even. Cost is the total amount required to sell an item, right? And that's before you ever create one item. It's all, it's what it costs to produce the item that you want. Fixed cost is what it costs you as a business owner just to open your doors. That's without selling anything. Profit is whatever is left over after you've sold everything and you've paid out all your money. Profit is what's left over. And then the purchase price is what you paid for the item. The retail price is the amount charged for an item before any discount. Revenue is the total money coming in, and we'll talk more about this when we get all back together. Sales price is the amount charged for an item after a discount. And the variable cost is, it depends on the number of items, what your costs are. Okay. All right. So here we go. Fixed cost is, again, what it costs to just open your doors, right? Variable costs is what each item costs to produce. And then revenue is what you're selling it for. So in this case, we're selling books, and what we're looking for is the break even. Okay, that's what we're looking for, is the break even. So remember, break even is the revenue and the cost are equal. Okay, so we have to set up the cost function. So cost function is your fixed costs plus your variable costs. So we come back and we go, okay, fixed costs are 92,000. Variable cost is 210 per book, right? So X is the number of books. And then this is going to equal our revenue. And our revenue is the price times the number of books. So P times X. So our price is $15 times the number of books. Well, we have a straight equation, right? It's just a linear equation. So we're going to solve for X. So we're going to bring our 210 over. And again, this is what I said. Most of the time I say move everything to the left. But if I move the 15X to the left, then I have 0 on the bottom, and then I have to switch it again. So you can move either way, whichever way makes it easier to solve. So 15 minus 210 is 12.9x, and that equals your 92,000. So again, you always want to divide by whatever is next to your x. All right, so the goal is to get x by itself. So 92,000 divided by 12.9 is 7131.78. So again, you can't have a partial book. So you need to sell 7,131 books, or 7,100, it'll say round to the next number, 7,132 books to break even. So to break even, I need to sell 7,132 books to break even. Okay. All right. Now we're at the last one. So this one, same thing. So we want to break even. So we have our fixed costs, we have our variable costs, and we have our revenue. How much we're selling the DVDs for. Okay, so I'm going to stop. I'm going to pause. And then when you come back, this one will be done. And let's see how you did. Okay, let's see how you did. 7,500. Hopefully that's what you got. So again, here's the setup. Here's your fixed plus your variable has to equal the revenue. And you sold them for $15.20 each. So we subtract 10.4, we get 4.8x equals 36,000, divide both sides by 4.8, and you get 7,500. So to interpret, to break even, I need to make and sell 7,500 DVDs in order to break even. Okay, that's 1.1. I'm going to stop there and we'll get 1.2 next, and polynomials.